This is Algebra 1, Unit 9, Lesson 3 on the square root function and shifting. Okay, so now we know that square roots are operations of numbers that give exactly one output for a given input. So it is a function that we can graph. When you plug in an x, you're going to only get one y. So when you plug in a value of square root, you get one answer. All right, before we graph it, we have to establish an important fact about square roots. Okay, let's consider the square root of negative 4. Why are either 2 or negative 2 the correct square root of negative 4? Well, remember that when you take the square root of something, what you are saying is that something squared has to equal negative 4. Well, can you do 2 squared and get negative 4? Nope, can't do that. And can you take negative 2 squared and get negative 4? No, you can't. Okay, so you can't square a number and get a negative. You can't square a number and get a negative because a negative times a negative is a positive, and a positive times a positive is positive. So you can't square a number and get a negative. All right, now if you try to do this on your calculator, the square root of negative 4, second square root, negative 4, and you press enter, it says it's an error. It's a non-real answer. Okay, so it is actually an imaginary number, the square root of negative 4, but we don't worry about that until you get to Algebra 2. In Algebra 1, we only deal with real numbers, and real numbers, the square root of negative 4 is a non-real answer. Okay, so all calculations result in a real number, so this doesn't work. Okay, so that tells us the square root of a negative number is not a real number. You can't take the square root of a negative number. It's called an imaginary number. Okay, now let's look at the general square root function, which is f of x equals the square root of x, or y equals the square root of x. You can use it either way because f of x and y mean the same thing. All right, choose values of x for the table that have rational square roots and graph them on the grid. Okay, so basically when they have rational square roots, you want a square root that comes out to be a nice real number, which would be any number that can be made into a fraction. Okay, so let's do the easy one. What's the easiest one you can think of? Well, let's use 0. All right, what's the square root of 0? It's still going to be 0. Okay, well, if we want rational numbers, we probably want perfect squares. What's the next perfect square? Well, probably 1. All right, the square root of 1 is 1. Okay, what's my next perfect square? It would be 4. All right, the square root of 4 is 2. And then my next perfect square after that is going to be 9. The square root of 9 is 3. Okay, so let's graph these. 0, 0 is here. 1, 1 is here. 4, 2. 1, 2, 3, 4. 1, 2 is there. And 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3 is right there. Okay, so as we draw this, it kind of looks like, whoops, pretend I can draw a neat line. All right, nice curve. All right, it goes up, kind of like that. All right, so what is the domain of this function? What do we know about the x values? All right, the x values start at 0. Can they ever be negative? No, because when you plug in a negative, it doesn't work. All right, so the domain of this function, the x values always have to be greater than or equal to 0. There can be no negative x's in this particular one. Okay, because when we take the square root of something, it has to be a positive. Okay, now what is the range of this function? Well, if you're taking the square root of a positive number, what kind of answer are you going to get? You're going to get a positive answer. So the range of this function, the y values, are also going to be greater than or equal to 0. Okay, so then we have, is f of x equals the square root of x always increasing, or is it always decreasing? Well, let's take a look at our graph again. If we have, as x increases, what are the y's doing? All right, here's the x's increasing, the y's are also increasing. So it's always increasing. Okay, now what shape does the square root graph appear to be half of? Remember, it goes like this. Well, doesn't that kind of look like a parabola? Yeah, it kind of looks like a parabola, and it makes sense when you think about it, because a parabola goes like this usually, but if we flip it on its side and look at only half of it, it's going to be a parabola. And it makes sense because a parabola is an x squared function, and a square root is the inverse of that. So that's going to be undoing the square root, so it's going to be half of a parabola. Okay, so since square root graphs are the inverse of quadratic graphs, that means square root graphs shift the same way that quadratics do. So let's take a look at the shift on this one. All right, so this is the graph of y equals the square root of x. Let me put it in my calculator so you can see it. Y equals, all right, I'm going to do the square root of x. And I'm going to adjust my window so that it looks like what's on the paper. All right, so that is from -5 to 10 for the x's. And for the y's, it is from -6 to +6. Okay, and I'm going to actually make it look what's on the paper. So instead of putting it in Y1, I'm going to put it in Y3 so it looks like the black one. There we go. Oops. There we go. So when I graph this, that looks just like what's on the paper. Okay. All right, now we're going to use the calculator to graph y equals x plus 4, square root of x plus 4, plus 2, and then list the values that you used. All right, so let me grab my calculator. Y equals, I'm going to put this in the blue one, the square root of x plus 4. Notice that's all under the square root. But the plus 2 is not. So notice this stops, this is still under the square root. If you do the right arrow forward, it stops the square root, and it's no longer underneath there, and then you put plus 2. All right, so let's graph this and see what it looks like. It looks like that. All right, let me look at my table and take a look at some values. We want some nice rational answers. You don't have to use the decimal ones, but you can. All right, so if I look at my table, I'm going to scroll back into the blue one until I can't find any more. Okay, now notice that when you get to -5 and -6 on this, it's going to be an error, because if you look at -5 and -6, -5 under here, -5 plus 4 is -1. That'll make this negative. So we want values of x that do not make the square root negative. So let's look at the ones we could use. Probably -4 would be a good one to use, and -3. Whoops, hit the wrong button. Sorry. Okay. All right, so -4 and -3 would be good ones to use. -4 is 2, and -3 is 3. Okay, let me graph those. -4, 1, 2, 3, 4, 1, 2 would be there. And then -3, 3, 1, 2, 3, 1, 2, 3. All right, I need a couple more to do. Another good one probably is 0, 4. That's probably another good one. 0, 4. 1, 2, 3, 4. And then scroll up and find a couple more. Let's see. I can use the decimal ones if I want to. Oh, 5, 5 is probably a good one. That should be enough, I think. All right, so let's use 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so my curve kind of looks like that. Okay, so is it the same curve? Yes, it is. Okay, so let's see how the function shifted from going to this to this. All right, so here is my starting point there, and here is my starting point here. How did we shift for the x values? All right, we went 1, 2, 3, 4 to the left. So we went 4 left. 4 to the left. And then what did we do for the y's? We went up 2. Okay, now that makes sense when you think about it. Remember when we did the parabola ones? What was inside the parentheses with a squared was always the opposite direction. So this means 4 to the left, and then this up here is the y. So this is the left shift because of the plus 4, and this is the up. Okay, so that is for that. So let's look at the domain and range of this function. Instead of being x is greater than or equal to 0 and y is greater than or equal to 0, all right, what's the x value, the smallest x value that you can use? Well, all the x values have to be greater than or equal to -4. When we looked at the table for this, -4 was the smallest y value that you could use, and anything past that was an error. You can see here. Okay, and then what is the range? Well, all the y values for this particular one, all right, the y values start at 2. So the range, all the y values have to be greater than or equal to 2. The lowest y value is going to be 2, and everything else is above that. Okay, so your shift for square root shifts the same way as a parabola. Okay, so since it shifts the same way as a parabola, let's see if we can predict how this is going to shift. All right, now this is under the square root, so that's going to be the same as being in the parentheses when you do a parabola. So if this is x minus 1, what shift is that going to be? It's going to be left or right. Well, if it's -1, it's always the opposite direction. It's going to go shifts right 1 for that part. And then the -4 would be the shift for the y, so that means up or down. It means down 4. All right, now let's see if we're right. Y equals, I'll put it in the red one so you can see it, the square root of x minus 1, and then stop the square root, right arrow, and then -4. So it should go 1 right and down 4 from the square root of x. Let's see if it did. Okay, 1 right, down 4. 1, 2, 3, 4. And if I take any point on the original graph, say I take this one right here, right 1, down 4. 1, 2, 3, 4. It's the same point on the other graph. So that shift is going to be true. Okay, so what is the domain of the red graph going to be? All right, where do the x's start for the red graph? They're going to start right there. So all the x's are going to be greater than, x's are going to be greater than or equal to 1. And for the y values, let's look, they're thrown away. All right, and the y values, the lowest y value starts right here. So the y's are going to be greater than or equal to -4. All right, and the y value is going to be greater than or equal to -4. Okay, so that gives you an idea about square root function and shifting. It works basically the same way as a parabola because it is the inverse operation. But remember, with a square root, you can't take the square root of a negative number. So any value under the square root that you have has to be positive when you work it out.